So welcome to the second lecture of RNNs or recurrent neural network. In the previous lecture, which was the introduction lecture for recurrent neural networks, we discussed a lot of things, starting from absolute basics, where we discussed that why do we need RNNs and how they are different from ANN or CNN architecture. Then we also discussed about different types of RNN, vectorization techniques, and finally towards the end, we discussed about few applications of RNN. And in this second lecture of RNN, we will take a closer look into its architecture and we will try to understand that how exactly the data is being fed to the model. I have considered this simple data set to provide you a good explanation. This data set has 3 data points, 1, 2 and 3. And only 2 columns. First is X, which is the feature column, and Y is the target column. If you will pay close attention, then you will notice that this data set has 5 unique words that I have listed down here. He is, tall, short and not. And I have used a very basic vectorization method in order to convert these words into numbers. So for the first word, the first integer is 1, rest are 0. For the second word, the second integer of the vector is 1, rest are 0 and so on. And now before we go ahead and start discussing about how this data or these vectors are being fed to the RNN model, there are a couple of things that I want to tell you and which are also very important, by the way. The data goes into the RNN model in a specific format, okay, which is something like this: timestamps and input features. This is the specific format in which we are actually feeding the data to the model. Let's try to understand timestamps first, okay. Let's say that we want to feed this data point to the RNN model. Now, as you know that RNN models accepts the data sequentially, which means this data point which has 3 words, which means 3 different vectors. This will not be fed to the RNN model at once, the way we used to feed to the ANN model. In fact, at a time, we are going to input the vector for 1 word at a time. And since this particular data point has 3 words, so the number of timestamps is going to be 3. And then next is input features, which is again, in simple words, it is going to be the length of the vector. So it is 5 over here. But when you will try to work on a practical project using Keras library, over there is a module that you will be using frequently, which is called simple RNN. And the way simple RNN module feeds the data to the model is slightly different to this. So prior to timestamp, we are going to have one more attribute, which will be batch size. Batch size, okay. So what is batch size here? Batch size is the number of data points in your entire data set. So in this simple data set that we have considered here, we have only 3 data points. So the batch size is going to be 3. And over here, the idea of timestamps will be changed. So even if you are feeding the data from this timestamp, which has only 3 words, okay, but still you are going to consider the data point which has maximum words in your entire data set. In this situation, it is this data point which has 4 words. So this value will be 4. And again, input features is the same size of vector, which is 5. This thing will make more sense to you once we start doing practical projects using Keras library. But for the time being, what you need to keep in mind here is that first of all the words in your entire data set, all the unique words, has to be first converted into machine readable vectors, the way we have done it over here, okay. Secondly, if you are passing one data point as an input to the RNN model, then the entire information in the data point would not be fed to the RNN model at once. In fact, it will be fed in timestamps. So in the first timestamp, you will pass the input of this vector he, which is here. In the second timestamp, you will pass the input of this vector, which is this one. And in the third timestamp, you will pass the vector for this particular word. If you are comfortable till here, then let's go ahead and move the discussion further. So these are all the unique words and vectors that we have from the data set, okay. And now we are going to understand that how exactly we feed this information or we feed these vectors one by one to the RNN model. So this is a very simple representation of an RNN model, okay. So I'll try to show you what I'm trying to represent here in this picture, okay. This figure is representing this structure over here. So it is a neural network which has 5 perceptrons or neurons in the input layer, 3 perceptrons in the hidden layer and 1 perceptron in the output layer. and I have taken this architecture and trying to represent it over here in a simple way. So let me erase these things first. Now please pay attention from this point. Okay, let's say that to this specific RNN model, we are going to feed the information of a data point, which is this: he is tall. Okay, so first of all, we take the vector of this particular word he, which is this one here, and it should look something like this. This will be 1 and these two will be zeros. This information will be provided to the RNN model. It will be passed on to the input layer and it will do something in the hidden layer and then finally to the output layer. Whatever is happening inside, we are going to discuss that in the next video. Okay, for the time being, our focus should be on this part. Okay, and I'll explain you what is that. Once we are done passing the information for this vector, then we take this vector. So it is going to be 0 here and 1 here. Now the information of this particular vector will be passed on to the model via this route. And this time, along with the information of this vector, the RNN model will parallelly input some information that it has captured from the previous vector over here. How exactly it is doing that? Just stick to the video and you will understand it. Okay. And once we are done with this vector, again we take the next vector and we start feeding it to the model. So this will become 0 and now this will become 1. And again, as we are passing this particular vector information to the model will pass itself some information that it has captured from the previous vectors. And if you are wondering that why every time we are passing the information of a new vector to the model, at that time, what is the purpose of passing the information of previous vectors to itself? And if you have this question in your mind, then it is a very valid question actually. And this is the main idea of working with sequential data. Okay, so let's consider this statement here. If I say that I am an Indian, okay, and in the next sentence I am saying I speak, and then I will ask you to predict the next word. In that case, you can guess any Indian language like Hindi, Marathi, Telugu, Tamil, but chances are very less that you will guess something like this: French, Italian, something like that. Okay, because these languages are not Indian. So how come you are able to come up with a good prediction over here? It is because as I was giving you this information, step by step, you were able to gain some information out of it. And you captured the information that I am an Indian. And this is why most probably I will be speaking an Indian language. So it becomes very important for you to capture the information from the previous data in order to predict the most suitable word over here. And this is the reason that every time you are passing the information of a new vector to your RNN model, then along with that information, it also sends back itself the information that it has captured from the previous vectors. So I hope that now it is making some sense to you. But to be honest with you, when I was learning this particular concept for the first time, it was very confusing for me to understand that how exactly this RNN model is sending back the information here. Okay, I was not able to understand that from where exactly this information is coming and to which point exactly this information is going. However, in this video or in this explanation, I am not going to leave you with that same confusion. So I have drawn a detailed structure of this RNN model to make you understand that how exactly it is happening. Okay, so this is the vector representation of the first data point, which is he is tall. Okay, and as you know that when we are working with an RNN architecture, this entire information would not be passed entirely at a time to the model. In fact, in the first timestamp, we will pass this particular information. In the next timestamp, we will pass this particular information and so on. So over here on your screen, you can see 3 architectures, 1, 2 and 3. But let me tell you that it is very important to understand that these 3 are not different figures, okay, or different architectures. These are the same architectures but at different timestamps. So it is the same figure at timestamp 1, then at timestamp 2 and then at timestamp 3. And on the first timestamp, we feed the first vector which is representing the word he. Okay, so it goes something like this: 1, 0, 0, 0, 0. It is taken in the input layer and through all the weights and connections, it is passed to the hidden layer. Now focus here at the timestamp 2. It is the timestamp where we will feed the information of the next word or this particular vector. Okay, so again we are passing 0, 1, 0, 0 and 0. This is being passed on to the input layer, and through all the weights and connections it is going to the hidden layer. But see, this time you will notice one more thing, that the information of the previous vector which was being captured by this hidden layer over here, this hidden layer is sending the information from the previous vector to itself in the next timestamp. So this particular perceptron is sending the information to all the 3 perceptrons within this layer only, and same thing is done by the other 2 perceptrons as well. But again, please keep in mind that these 3 perceptrons and these 3 perceptrons are exactly the same. So please don't assume that this is a different layer and this one is a different layer. It is not like that, okay? These are the same layers and same perceptrons but at different timestamp. So assume that on day 1 you are doing a voice recording, on next day take your medicines after lunch, and on day 2 you are confused that if you should be taking the medicine before lunch or after lunch. So on day 2 you are listening to the same recording that you recorded on day 1. So on day 2 the information is not coming from someone else, it is you only, but from a different timestamp. Okay, so the same thing is happening here as well. And again on T3 in the next timestamp, when you are feeding the information of the vector representing the third word over here, which is 0, 0, 1, 0, then again along with this information from the third word, the hidden layer is again sending back the same information captured from the previous vector. So I understand this figure has become a bit messy and it is a bit difficult to understand, and this is why at the first point I was using this simplified version, okay? And ultimately if you are able to understand with the help of this simple figure, then that is enough. All we are saying is that every time you input a new to your RNN model, then along with the information coming from that specific vector, it will also feed itself the information captured from the previous vector. And if you are able to understand this much, then it should be the main takeaway from this specific lecture, okay? In the next video, what I'm going to discuss is, we will pay close attention on all these weights. We will try to understand that how many weights we have here, okay, and how exactly the forward and backward propagation is happening. So the next video is going to be really important, so please do not miss that. And my humble request will be there to drop a like below if you found this video helpful. Consider subscribing as well if you are new here. In this playlist, I have already covered the topic of ANN and CNN, and I'm trying my best to cover the topic of recurrent deals within 4 to 5 videos, okay? So you can consider pressing the bell icon as well. You will be notified as soon as I upload the next video. Thank you very much for watching till the end. You have a nice day ahead.